Okay, I don't know if my mic, oh, there we go. We got it back on, all right. Can everybody hear me okay? Just give me a quick nod. Awesome, okay. Just got a couple people trickling in, so I'll get started in like 30 seconds or so here, and we'll get going. All right, it looks like we've got folks in who are going to come in, so let's get started. First of all, if you've got any questions, this room is gigantic, so it's going to be hard for me to see you, so I apologize in advance if you were trying to flag me to ask a question along the way and I just didn't see you. It's very hard with these pumpkins looking at me here. So I apologize, but I'll stick around after for any questions you have. I'll try and catch you and go through them. So with that, I just wanted to open up by saying what this session is all about is it's kind of a use case session. It's all about how Halo 4, as you saw in the keynote, has kind of transformed how they think about investment they make in that game in terms of adding more levels, adding more weapons, improving the multiplayer experience, etc. They've really transformed how they've gone about this in the fourth version of Halo from a, this is what we think users would want. We've talked to a couple of them. It sounded good. To, now we can measure exactly what users are doing by recording what's going on in the game from everything around what users select in the game, how long they spend in a level, who they talk to, the network conditions at play when a game is going on, et cetera, et cetera. And so now instead of guessing, they can be very analytical and very kind of measured about the investments they make in a game. And so what we wanted to talk about today is a little bit about, one, what was the challenge? What were they trying to do? But more importantly, what is the recipe that they followed to get their Hadoop infrastructure up and running relatively quickly to power the launch of Halo 4? And so this is kind of a follow-on of what was talked about in the keynote today, where we're going to try and take a bit of a deeper look and see exactly how they put this thing together. It started out as a small team, not Hadoop experts, and they used a lot of building blocks that are all available today to get their infrastructure up and running. So with that, let me give you a little bit of an insight into Halo 4 itself. If you're not a gamer, it really doesn't matter. It's more about the type of data, the volume of data, how it was being handled. And so these are a few stats about Halo 4. The game was released late last year. You can see in 24 hours they hit 220 million sales. And so immediately this thing was a big data problem. If you think of 220 million people doing something, and you think about not just human-generated data, but machine-generated data as they're doing it, the problem explodes really quickly. And that's where the team that I work on within Microsoft, which is our big data team at Microsoft, partnered with the Halo guys to kind of help them tackle this problem out of the gate. And so they had, it's 4 million plus players into the game in the first 5 days. Out of the gate, they knew they were talking hundreds of terabytes. With that's just expanding rapidly all the time. Every time I talk to somebody on the Halo team, they give me a bigger, newer number. Which is awesome from a platform perspective, because we have a great test case to kind of prove out our platform internally as we add new features. And lastly, they're logging millions of game sessions a day, and we'll look at exactly what a game session is and how they're making use of that data. So it's a fairly significant problem from day one that this team went after tackling. And for them, why they decided to do this instead of going the old route, well, part of it, if you're at this conference, is probably pretty obvious to you. But for them, what they really wanted to do is said, look, we know there's a lot of questions we want to ask. We don't know what they all are up front, but we know there's a ton of valuable data. And so they wanted a solution where they could store first, figure out the questions later, do it at scale, and do it cheaply. And so that was kind of the goal coming out of the gate, where the initial bar was set at hundreds of terabytes, knowing that that was going to scale pretty quickly. It was not a team of Hadoop experts. And so they needed to be able to take skills that they already had, apply it to the problem, and then quickly, the most important part, get to analysis and get to insight on top of this data. And so the goal was collect this data, help them process it at scale, get the infrastructure up very quickly in an order of weeks, and then quickly get that from raw data to insight. And so really looking at a new approach to understand their customer. The rest of this session is structured in 3 stages. The first stage is kind of a broad look at how they put their Hadoop solution together. And I tried to focus on the Hadoop-specific parts of the solution along the way. So we're going to look at the architecture picture all up. Once we do that, the next step will be to look specifically at how they put this together. What components they used, what Hive scripts they ran, what pig scripts they ran, et cetera. The caveat is it's all mocked data. You're not looking at live Halo data. That would be a no-no. But the approaches and styles are directly taken from how we solve this problem in the production system with Halo. So we'll look at the pieces and how they came together. And then the last bit is the insights. We'll look at, once we made the elephant dance, what did we do with the data that he emitted? Right? How did we actually turn that into actionable visualization that the marketing team in Halo, the game team, et cetera, could action and work on? So we'll work in these 3 chunks for the rest of the session. So as I mentioned, first bit is architecture picture. Fairly high level, but the idea is that at any given time, there's millions of players playing Halo, emitting their session data information. That data is coming into our cloud platform. They didn't have time to procure hardware. They didn't have time to think about sizing, et cetera. They needed something that they could get up to speed quickly and then it to grow with them. And so what they did is they're constantly pumping up data into the Azure cloud platform, and they put it first into kind of a landing zone. A landing zone could be persistent store, where the persistence is kind of a temporary thing. It's you keep it there for a while until it moves down the pipe. Or it could be an in-memory solution where you're seeing an event come in, doing a little bit of processing and pushing it along. So the blob store or in-memory landing zone is simply a place to present a landing target for all of these Xboxes out there that are pumping up data. The next phase in the pipeline is a curation phase. Curation for them means, it means a lot of different things. Usually this is use case specific, depending upon what you're doing, but there are some general steps. In their case, you're thinking about things like scrubbing the data, masking out personally identifiable information, whatever the governance rules are, corporate policy, et cetera, that you work under, this gives you a nice spot within your pipeline to perform those actions. We see that a lot where, depending on what country you're in, you're under different rules. And so you need to be able to kind of manage that in a way as the data is coming into the system. That's the curation phase that we built. The last piece is actually the big data store, represented as blob storage, persistent storage in the block diagram. So after the data comes out of curation phase, it's landing in our blob storage. Blob storage is a service in Azure, our cloud platform. You can think of it kind of like Amazon S3. Basically, it's a big disk in the sky that you can keep pumping data into. Doesn't matter what shape it is, serialization format, et cetera. As you pump data in, it will grow with you. You can have multiple blob store accounts, et cetera. You kind of get the point. Big disk in the sky. For them, that is their long-term store. That is big data for Halo. They have a bunch of data up in blob storage in our cloud platform. It's geo-redundant, et cetera. That is their big data corpus. And then when they want to ask questions over that big data, they spin up Hadoop clusters and attach those clusters to those blob storage drives in the cloud. And the Hadoop cluster is attached to the blob storage drive and then operates on top of it. This is done using the abstract file system interface in Hadoop so that the Hadoop stack sees blob storage just as it sees HDFS. And so Hive, Pig, Cascading, Scalding, pick your favorite project in Hadoop that you want to use, just works. And so for them, for Halo, they're using a lot of Hive queries on top of their big data storage in the cloud to ask a lot of questions. And what they're doing is they're spinning up oftentimes more than one Hadoop cluster to solve their need. And the way that we stand this up in the cloud is that the act of bringing up a Hadoop cluster, we used to think about this a couple years back as an event. I'm going to plan for this. It's going to be some time. I'm going to get some hardware maybe. I'm going to set it up and configure it. What we really tried to do with the cloud platform is make it really simple to create new clusters and tear down clusters. And so for the Halo case, they were able to create a new cluster in anywhere from about 15 to 20 minutes, bind it to their storage, and go. That opens up a lot of doors for them. What it did is it enabled them to, 1, quickly spin up a production cluster, 2, quickly spin up a test cluster, and then 3, get all of their developers access to clusters very quickly. You could spin up a 1-node cluster for your developers, a 40-node one for your production cluster, et cetera. So they were able to get themselves up with Hadoop in front of their developers the day they decided to go this route, which is a pretty powerful thing. And so that's effectively the overall landscape. Now let's look at each of these steps along the way and how they're built. The first part is when data's first coming into the system. In this case, the data comes in a very raw binary format. It comes in very small chunks. It includes some data that we don't want to store for the long term for whatever policy reasons, governance policy, et cetera. And so what happens is that data comes in small chunks. In some cases, we might persist it to do some processing on. In some case, we pass through in memory. We have a curation phase. A curation phase, in our case, is what does the scrubbing, what does the dropping of data. It also takes many small blobs, kind of aggregates them into one bigger blob, so that when we bring Hadoop to bear on the data, things are a little more efficient, because Hadoop works very well on larger files. Our curation phase is built actually using a Hadoop cluster as well. And so we talked about how easy it is to bring up and spin up Hadoop clusters. In this case, there's a pig script that is acting in the curation phase. But there's also some other custom code that gets run here. Coming out of the pig script, data gets stored into blob store in its long-term format. In this case, it's optimized in that it's of a nice size for Hadoop processing. It's already been cleansed, so it can stay there for a long time. We don't have to worry about any policy issues. It's been partitioned coming out of the curation phase so that from a Hive table perspective, the data is well organized and can be queried efficiently. And it's well defined from the standpoint that we know what it is, we know where it resides, but it's still semi-structured. It's still raw data that's existing in our blob store so that we can ask all kinds of questions over that raw data. So that's the basics of the pipeline and the reasons for the 3 steps that exist in the pipeline for Halo 4. Now what I thought I'd do is take you through kind of the building of each of these phases in the pipeline so you can see kind of from a logical view how these things came together. And we'll look at a few scripts along the way that are emblematic of what they run. Not exactly identical, but fairly emblematic so you can see how you'd put this together yourself. And so for that, what we're going to use is something called HD Insight. HD Insight is just the product name for Microsoft's Hadoop as a service built on our Windows Azure platform. And so when you see HD Insight, you can just think Hadoop in the cloud. And I'm going to walk you through how they used HD Insight to build out that pipeline, along with other aspects of our cloud platform. So let's get out of slides and start to look at some of the pieces. Great. So where I'm sitting right now is I'm logged into my Windows Azure portal. I've got 3 running clusters, one in an error state. If you're at my session earlier, you'll know why it's in an error state. But we'll skip that. I've got 3 running clusters. What the Halo guys first needed to do was get a cluster. Like from day 0 when we said, OK, we're going to store a bunch of data. Now we need to process it. The first thing we needed to do was get a cluster. This is what you have to do to get a cluster for the first time. You go New, Data Service, HD Insight, Quick Create, give it a name, tell us how many nodes you want. This equals how many processing nodes. Give yourself a password. Specify the blob store account you want to use to bind to that cluster, and click Go. 15 to 20 minutes later, you have a full functioning HDP cluster running in the cloud that's running Hive, Pig, all of the common Hadoop services. And so what they did out of the gate after that first meeting was go run this wizard, get themselves a query, start building a proof of concept. Literally that day, they were in building proof of concept mode. And as we built this out, the first thing you want to do when you're taking something from proof of concept to actual solution running in an enterprise is you want to get out of tools like this after you've learned, and you need to be able to script things, make them repeatable, make them easy to run. And so the evolution of them spinning up clusters as part of their pipeline was to move from UI tools like this into a command line scripted experience where from a single command, they could spin up a cluster in the cloud of arbitrary size in whatever geolocation they needed to spin it up to. And so what that looks like for them is something like here. There's a command, a set of commands that we've built. We've built a couple of different ways to do it. Given the audience, I thought I'd talk about our CLI tools that we've built on top of Node.js. If you're familiar with Node.js, it's a JavaScript runtime. It runs on Linux, Windows, Mac, etc. So if you're a user wanting to build out a pipeline like Halo has, if you install the Node.js runtime, this is the command to do it right here. Once you've installed that Node.js runtime and installed, our package, that's the command to install our package. I apologize for misspeaking there. Once you've installed our package, you're going to get presented a set of command line tools like this that allow you to spin up Hadoop clusters from the command line with one command. This is saying, spin me up a cluster of this name with 40 nodes in this geographic location. Could be North Europe, could be East, could be West US, etc. Here's the location of the storage account. That's that big disk in the cloud that's holding my data that I want you to bind to. And here's my username and password for the admin account of that cluster. And so what they got to in building out their pipeline, the first thing they had to do was script the creation of their Hadoop clusters that were going to be bound to those storage accounts that's holding their data. And so they wrote a script using these command lines to be able to spin up clusters as they need them and take them down when they don't. So that's the simple case. There's a slightly more involved case of creating clusters as well, where you're allowed to create a cluster off of a JSON configuration file. The only reason I'm bringing this up to show this is that if I wanted to create a cluster and specify all the basic information, but let's say I create a Hadoop cluster and I want different developers to work on different aspects of my solution, but we all want to share common metadata, meaning we all want to have similar Hive tables over top of our data. We all want to have similar Uzi artifacts. And what we want to be able to do is when we spin up a cluster and use it for a period of time and then take it down, when we spin up a new cluster, we want to be able to reuse all of those metadata artifacts. With every new cluster, I don't want to redefine my Hive tables, my Uzi workflows, etc. And so with a configuration file like this, we can externalize our Hive metastores, Uzi metastores, etc., and during cluster creation, allow you to bind a cluster to a blob store account, to a Hive metastore, to an Uzi metastore, so that that cluster becomes an execution unit that's easy to spin up, take down, etc., but all your data and metadata persist beyond the lifetime of a cluster. So these are the initial building blocks that the Halo team used to start to get up to speed when creating clusters to build out their pipeline. The next piece in the journey was, now that you've got a cluster, it's easy to script to create, easy to set up. The next piece in the journey was to actually look at the data, right? It's all about the data. And so data for them looks something like this. Now, this is just mocked, but it gives you the idea. This is for one user, user number 2277. It's a good name for that user. This is basically the start of a gameplay session, when he started playing Halo, or she, how long they might have played Halo for, what IP address they came from, was it a multiplayer game, how many weapons did they use. This is a list of other user IDs that person interacted with during that game session. So this is just a snippet of the type of data that comes from the Xbox into the platform as users are playing different sessions of Halo. This is a mocked version, just so you can get a feel for the data and we can look at it pretty easily. But this is the type of data that's coming in. I mentioned as this comes in, it gets to a landing zone, and then you want to do a curation step on that data. For them, curation was spin up a Hadoop cluster, like I showed a second ago with that command line, and do some form of processing. In this case, we're doing processing using a pig script. This is just an emblematic example. They don't do exactly this, but it gives you a flavor for the types of things you're doing during curation. In this case, we're loading that raw data. We're loading a dictionary of IP addresses to geolocations. We're doing a join across the raw data and IP addresses to basically geo-encode our raw data that came in from the Xbox so we can add location information based on IP address. Once we've done that, we go and mask out part of the IP address so that we no longer know exactly where that user was. We take out the last octet, depending on where you are. Sometimes that's required for policy reasons. And then the last bit is to store the data after it's been processed into its final resting place. And for us, the final resting place was another blob store location. But you can notice at the end, the location is fairly well organized, meaning the data goes into a specific year, a specific month, a specific day. And so on its way in, it was very raw. We enriched it, we masked it, and then we pushed the data into a specific location that helps us with partitioning for our queries down the line. And so we've got kind of our partition information encoded here. Once we've got that data that's gone through our curation step, we start creating Hive tables on top of that data. And the way that that gets done is pretty simple. Let's go and look at a couple of the scripts. I'll show you one really quickly. We went and created this Hive table on top of the output of that pig statement. This Hive table basically says, look at the curated data through this lens and apply this partitioning scheme of year, month, day. So we started out with raw data from the Xbox. We did a little bit of masking. And then we let the data reside in a blob store that's been fairly well organized and also in a way that allows us to partition it fairly well using Hive partitioning. This allows us to write statements like this one to create partitions where we can create a new partition for every day of a month. That way, the Halo team can come along and easily ask questions, what happened today versus what happened this month versus what happened this year, and then also more granularly if they want to, and do it in a very efficient way. Because as things come out of the pipeline, it's well partitioned. So literally what they've done at this point is they've got a nice Hive view over top of their data that's been well partitioned, and then that's where they start writing interesting queries on top of their data. For them, an interesting query might be, this is again, a mocked query, something like this, where don't worry about kind of looking at every line. I'll give you the gist of it. This query basically says, for the month of June, tell me all of the data that came in that represented a new user, one we haven't seen before in our big data store, and filter out by the users who have had gameplay durations greater than 2 minutes, meaning somebody new came into the game and they played for at least 2 minutes. If they played for something less than 2 minutes, probably it was noise. They started it up and then went and had lunch and never really played or something like that. So we're trying to figure out who are all the new users that have played for more than 2 minutes. The idea of this isn't that, wow, we're going to have this great insight by a list of new users. The idea is that we're taking a lot of data that's coming in, stripping it to a fairly small subset, and then making this data available to our analysts. So what we think about here is this data is representing kind of a result set that can be further analyzed and sliced and diced and visualized to understand the behavior of these new users. Because our goal for this particular flow was to understand behaviors of new users in Halo and how our various marketing efforts were affecting those users. So at this point, we've got a table populated called new engaged users that we then want to make available to our analysts to slice, dice, and visualize to understand better. And so up to this point is basically data ingested, Hive tables on top of that, a bunch of standing Hive queries to slice and dice the data, and then the output of those queries being made available to our analyst. And let me show you how that comes together. We'll switch back. And so what we talked about before is, for them, the goal was all about understanding their users, right? I basically, in the last 10 or so minutes, have taken you on kind of a whirlwind tour of some of the pieces and parts that the Halo team has used, all just stock Hadoop pieces that are available today to put together a pipeline very quickly. The output of that pipeline, if you remember our architecture diagram, was a bunch of big data that had been curated with a Hadoop cluster attached to it, and that Hadoop cluster producing result sets. In our particular demo example, the result set is all of the new users from the month of June, right? The next phase in that is better understanding of those new users. And so for them, it was all about how do we then take this data that we've now collected, we've curated, and we've processed and sliced, and make that available to analysts. This goes back to what Quentin was saying in the keynote this morning in terms of how do we make big data available to the average user, or at least to the average analyst or business worker. And we believe that's through Excel and the Excel suite that goes online. And so what we've been doing is, as a product team working on big data at Microsoft, is really working on the connection between our big data platform and our BI tools. And so the next step in the session is to show you how that works. Once you've got the output of a Hive query, how do you go from that raw output to data in Excel, to rich visualization, to something that you can look at and take meaning from? And so I'll show you how that came together for Halo. Let's come back. There we go. All right. So at this point, we had just run our Hive query. We've populated our new engaged users table. We've got that result set. I'm going to open up Excel. What I've got in Excel already was a data I've loaded out of a SQL Server database. This is just data about marketing campaigns that were being run in a particular time. So on this day in the city of Oakland, we were running marketing campaign in game 1, and we got 29,000 impressions. This is just marketing data from a standard SQL Server database. I'm sure everybody believes me. We know how to get data from SQL Server to Excel. Now, the interesting part is how do we get data from the output of our Hive jobs into Excel to combine with this and create visualization. And so for that, we've taken something called Data Explorer, which is a great way to pull data into Excel, and added in Hadoop integration just specifically for HDFS as well as for our Hadoop in the cloud service called HD Insight. And so if I select HD Insight and I point at my specific Blob Store account that's running this demo, it shows me all the data that I have available. I made one called Summit that's a mock-up of our Halo data. I'm going to go look for the new engaged users table. Here it is. I'm going to select that. It's a bunch of comma-delimited data, just like we saw before. I want to get this into Excel, so I'm just going to say, actually turn this into a table. It's delimited with a comma, so slice it that way. That's cool. The first row kind of looks like my headings, so I'd like to just promote that to the heading of the table, because it was a CSV file, so it had it at the top. That's cool. So now I can see kind of a table of my data, and the day column is a date, so I want to tell Excel, go ahead and format that as a date so that you can treat it that way. I don't care about this multiplayer column because I've always selected by only multiplayer sessions, so let's hide that. There's a bunch of other data about this game sessions. All of them are numbers, so I'll tell them, well, treat this type like a number. Great. And let's call this game data, or game info. And go done. And what's happening right now is my laptop's literally connecting to our service in the cloud. It's pulling down the result set, new engaged users. In this particular case, in my mock data set, there's 720 rows. This isn't standard Excel. This is using something called Power Pivot, which is our in-memory analytics engine running inside of Excel. This thing will scale to millions of rows. So don't think 720, a couple thousand, think millions. And so at this point, I want to load that into my in-memory model. Awesome. Now I've got game data as well as that marketing data sitting inside of Excel. The next thing we want to do is visualize. And so for that, we're going to use something called Geo Flow that you saw a little bit of in the keynote this morning. And we're going to start with a blank canvas. And the first thing we want to do is start to put this sucker onto a map so we can start to visualize. So the first thing we're going to do is add our marketing data. We have city and state information. So let's map that. All right, it was all the marketing campaigns in those days were running on the West Coast, shown by the dots there. And lastly, let's make the number of impressions equal to the height of the bar, so you can see how many impressions we were getting down the West Coast. And we want to look at this data by day, so I'll select day there, and do all this by day. Actually, remove this guy, and bring day, sorry about that, here. Look at day here, great. And we're going to do instant. So now what I can do is take a look at my marketing data over the course of days and start to play it and see how things change over days. So hit day number 4, great. So now we've got our marketing data on the map. It doesn't look so great that way because I want to layer things on top. So instead, I'll just make this a bubble so we can see now where various things were happening. So you can see where our impressions were happening on particular days, in this case, June 3rd. Now, on top of that data, we want to start to place some of our game data. And so let's add a new layer to the map. And let's place game data. Here's my game info. Remember, we geocoded it in the curation step to include the state information. So let's add state. Great. Now, to that, let's make the size of the thing on the map equal to how long a new user played. So let's height equal duration of gameplay. OK, cool. Now we're starting to see a little more perspective on how people played the game. Let's also go and say, well, we'd like to see all this data organized by day. So there we go, by day here. And lastly, I want to slice the data in different ways. First I'm going to do is slice it by the number of weapons somebody used in the game. And we'll do clustered. And let's zoom in a bit and take a look at what's going on here. So we can start to see various data points show up. And so let's come over on June 1st. You can see what's being visualized right now is in the red blobs where marketing campaigns were being run. The bigger the blob, the more impressions were being pushed to users. The bar charts are showing me how long that new user or that class of user was playing the game. That's the duration information. And the reason for the clustered bars, let's see if I can get my legend to come back. Here we go. The reason for the clustered bars here is to show you, based on how many weapons somebody used in the game, did that affect how long somebody played? Meaning, if somebody started playing and started picking up all kinds of artifacts in the game, did that lead to a more immersive experience that caused somebody to play more? Or was it just that there was a bunch of marketing information going on around them that led them to play more? In this particular case, I don't see any correlations. I don't know if you guys do, but this looks pretty random to me at this point. So I'm not getting a lot more insight than I had before. And so at this point, I'm going to say, well, weapons used didn't really create much correlation. Now let's add interacted with. Now I'm starting to see a little more correlation. Let's start to add back marketing information, and let's look at the 1st of June. We can see kind of across the US, you can see those yellow bars are quite high. Yellow bar represents a new user interacted with at least 5 people in the game. And so the yellow bars are high, saying the more people somebody interacted with, the more immersive the experience was, the longer they played. So now I'm getting some insight that says, one of the key metrics to drive kind of an immersive experience is encouraging people to interact with more people in the game in a multiplayer setting. That really starts to draw them in, as shown by the behavior. And you can see on the far right, we were running a couple of marketing campaigns, but they weren't really working because we're not really seeing a bunch of minutes of gameplay off in the West Coast. So that can tell us whatever money we were spending on that campaign may not be worth it, right? We're not seeing that pop, right? I'm an engineering guy, of course. I don't show that the marketing campaign works. Sorry, Val. But as we go and change the days, you can see how gameplay changed. Well, now you can see on June 4th, we can still see that correlation. The yellow bars are the biggest bars. That's when people interacted with the most other users. They played the most minutes. But you can also see some anomalies starting to pop on the West Coast now. So if we come around to the West Coast, we can see, yep, as you interacted with more people, people played longer. So definitely something we can do there with our campaigns to entice people to reach out to other users, because that creates an immersive experience. But then if you look and see, well, on the 4th, we were running, again, a set of marketing campaigns on the West Coast, and we're seeing some anomalies in minutes played. We're starting to see a big spike here and a really big spike over here. And so whatever campaign we were running on June 4th was clearly having a much better effect on users than whatever campaigns we were running on June 1st. Because if we roll back the clock, we can see, like, June 1st, not much was happening, right? June 4th, a lot more was happening. And so we can see, one, that what marketing campaigns were working for us, what weren't, and two, what metrics were actually causing more stickiness in the game, people to play longer. And so it wasn't until we can get this kind of visualization that we can really start to see some new insight in the data. And what I just did right now was actually live. There was no kind of mock data sitting on my laptop, et cetera. All of it was done against our cloud service, a running cluster, a running blob store account. It literally takes that long to go from data in Hadoop to this kind of visualization. So you can imagine what the guys at Halo are doing with data all day. As this is pumping in, they're able to slice, dice, visualize the data, really understand what's going on. It completely transformed the way they think about investment in the game. From user interaction all the way down to measuring network effect in terms of what's the lag between two users during a multiplayer session during a particular point in time. Do we need to provision more hardware there to have a better experience? These are all the types of things that they're doing, both from a looking back perspective and more looking at predictive analytics looking forward. And so this is the kind of thing that we're trying to enable with Hadoop, is really make it simple to go from creating clusters, scaling them out, getting them going, storing data en masse, asking questions using all of the Hadoop ecosystem projects, Hive, Pig, et cetera, and then getting it into tools like this where you can visualize and make sense of the data very quickly using the skills you already have. And so for us, partnering with Halo was an awesome experience. We got to vet out our cloud platform as we built it. Halo got some benefit because they're quickly getting information like this that they haven't before. It was really an awesome partnership to get to work on. It was pretty cool. And so with that, let me just jump back into our slides. We've got about a minute and a half left, so I thought I'd jump over and just invite anybody to ask questions about what we've been doing with Hadoop, anything they saw today. I'm happy to stick around after to talk about more of the details on how this came together. But as I mentioned, it was basically a quick project that came up. We spun up a proof of concept, got it going, got their pipeline live, and they've been running the pipeline since the launch of the game up in our cloud infrastructure, getting those kind of analytics and those kind of results. So with that, I just wanted to thank you all very, very much for your time. I really appreciate you coming to the session. If you have any questions, I'm happy to take them. Thank you so much for your time.